loosen, maknanya telah longgar. The chair can be used. When you use it, the chair it still can use, but it's not strong enough, not firm enough to sit on the floor. Okay, not firm enough to sit on the floor. So this can be considered a major non-conformities. So it just take some time to be failed. Okay, after a few times using, somebody is moving while sitting on a chair, okay, and then finally it can cause failure. Another category is we call it minor. Minor ni is just like appearance lah, so it doesn't affect the functions. It still can be used, and it is not effect in terms of usability of the products. Okay, so in this one sama juga, it's the same, but here we put it W as a weightage. Okay, so this is easier to understand actually. So we use WC, UC. Okay, WC mean W for critical, UC ialah U for critical. Okay, plus WMA, W for minor, for major, U for major. Okay, U for major, and then we plus more W for minor, U for minor. Okay, so these are the weightage WC, WMA, WMI. These are the category of seriousness. Okay, U is the ratio, count non-conformity per unit for each category. Okay, you have critical category, major category, minor, and this weightage that I say that depend on this suitability. In previous slide, in previous class, we use W yang critical tu yang apa ni, yang the first category, yang seriousness in term of very serious tu, kita letak 100. Okay, after that kita guna 50. So you can also use this ratio, critical 9, major 3, and minor 1. So this is easier to use actually. Okay, so and then this become the D values. Okay, 9 UC plus 3 UC. Okay, 3 UMA plus 1 UMI. Okay, so what you put in the chart, this value, the D value will be plotted on the chart. Okay, okay, let's see this. Okay, so the central line. Okay, using the what do you call this? The stable values lah, the weightage here, and still the same as we are calculating for the other points. This is central line, and this formula 9 UC is same as here. The difference is you have the note here. Note here means the standard, it has been established. The standard for critical, for major, and for minor. And the central line, okay, same, the formula is the same. The difference only you have the weightage here. Okay, the weightage square here, this is square, this is square. Okay, and the control limit is given by, okay, so that demerit chart, you're going to have, this is a center, okay, the center. Okay, the center will be here, and then upper control limit. Okay, as usual, the center line, okay, will be plus 3. Okay, standard deviation, okay, of the U. Okay, which is D is coming from here. Oh, sorry, not this one. Sorry, it's coming from. It is coming from here. What is coming from here? Okay, this. Okay, so lower control limit. Lower control limit is this one. Okay, So this is demerit per unit chart. Okay, let's see example here. Assuming that a 3931 3-class weighting system is used, determine central line and control limit. Okay, given, okay, this is given, the ratio, the standard ratio for critical is 0.08. Okay, the standard ratio for major is 0.05. Okay, for minor is 3, and we have n equal to 40. Okay, n equal to 40. Right, so we calculate the demerit unit. Okay, so we need to calculate the demerit unit. Let's say, for example, for May 25, okay, what will be the value for that D? Yeah? Given that inspection on May 25, critical non-conformities, we found that it is 2, okay, C equal to 2 for that particular day. And critical 2, major non-conformities, okay, major non-conformities. Okay, we have critical. Okay, we use C as critical. Okay, I follow this C. Yeah? C is for critical. It is 2, and then we have major, AMA. Yeah, I use MA here over here. So you have 26, and minor nonconformities MI equal to 160. Okay, minor is many, but actually there is not be a problem because functional is not effect. Okay, just appearance. Critical, even though it's 2, but it is serious. Okay, it's serious. So major, it was 26. Okay, in the middle between critical and minor. And how many we inspect here? We inspect, and here we inspect the number that we inspect is 140 unit. 40 units. Okay, how come you have 160, 26, more than 40? Because these are defects. Okay, defects are non-conformities. Okay, in one unit you can have many defects. Okay, you can have scratch, you can have hole, you can have crack. Okay, even one piece of product that you inspected. But we inspect only 40. Okay, inspected on that day, on this particular day, on 20th May, we inspect 40 units. Is the May 25 subgroup is in control? So the question is it the process okay or not on the May 25? Okay, so remember that we need to use this for demerit chart. Okay, demerit chart. So we have to establish the center line. We have to establish the sigma values so that we can get the control limits. Okay, so central line is given here. Okay, this is central line. Central line, if you have it here, okay, that will be the central line. Okay, center line, and you have control limits. Okay, so D node is central line, okay. We get all the values into this formula. Where you get 9? 9 is the weightage. 3 is the weightage. 1 is the weightage. And U node C already given. Okay, U node C, U node MA, U node MI. U are the ratio between number of conformities divided by N. Okay, how many that we inspected. So in this case, it's already given. Okay, already given here. So we just use it. Okay, already given here. Okay, if not given, we have to find this, meaning that we have to total all. Okay, we have to total all the unit of critical. How many critical for the whole duration of inspection? Okay, and then you have to divide by how many that we inspected. In general, we know that U is C over N. C over N. C here is number of critical defects that has been observed. how many critical that we have observed. So to get this OUC, meaning that you have to get summation of all the critical. Okay, how many criticals defects? Okay, defects, critical defects. So in one unit you can have more than one defects. Okay, critical defects. Divide by n. N is okay, how many that you inspected. So because you want to get the center of this estimate, there also must be summation of n. Okay, okay, maybe some places they might be using slightly different symbol, but the meaning is that you want to get okay the mean of this what we call it the estimated ratio for critical defects. Okay, the estimate of the ratio for major and also for minor. Okay, so that is given. We put it in this formula now. Okay, already given here. We put it, and finally solving this, we multiply this with the weightage. So you get it D equal to 5.2. Okay, 5.2 defects is the mean. Okay, so another important part is we have to find the sigma. Okay, sigma, the standard sigma for this for the U. So it's given by this formula. Okay, the weightage given U not C, U not A is already given. Okay, just put it here. Instead of 9, we have 81. Okay, we have 81 here. We have 9 here, which is 3 multiplied by 3 and 1 here. Okay, divide by n, which is 40 for that duration, and you have this 0.59. Okay, so the central plus 3 multiplied by sigma here, you get 7.0. Okay, so upper control limit equal to 7.0. Lower control limit will be equal to 3.4. Okay, going to be 3.4. Okay, so now on May 25, okay, on that particular day, you collect more data. Now you want to check, okay, whether this process is stable or not. So we assuming this is coming from a stable, assuming these are coming from a stable process. Now we can use this control chart for monitoring future process. Okay, so the formula that we need to know now is how to get the D value. We already know the D value is given by this. 9 mu C plus 3 mu MA plus 1, sorry, U, not mu. This is 9 UC plus 3 UMA plus 1 UMI. Okay, so how do we get UC equal to 2 over 40? Okay, so UC, we know that the critical was 2 in the formula, in the problem is given the critical was 2. Okay, so how many we inspect? 40. That's how we get it, this value. And the measure, we have the measure was 26. So now we want to get the ratio of this measure. 26 divided by 40. That's how we get it. Okay, and the minor. Okay, we know that the minor, so many minor. How many? 160. Okay, so the ratio for the minor is 160. How many we inspect? 40, that's what we expect. Okay, so we get all this number. Now we use all this. Okay, ratio, put it in terms of weightage. Now we get the value for D. Okay, D for May 25. So D, and then solving this, we got it 6.4. So now we check 6.4. Where is it? 6.4. Okay, 6.4 is still within the control. Okay, let's say that we have here is, let's say we have it here is Okay, so this is, let's say, May 25, okay, or 20th of May. Okay, 20th of May is here. And then 6.4, it will be inside here. Okay, so our conclusion, okay, considering different classes of defects in terms of its seriousness, our conclusion process is in control. Even though we have 160 for minor, it looks so many, but because of this is not something that's serious that affect the function, okay, when we calculate in terms of weightage, actually it's not serious. Okay, see here, if we don't use demerit system, our decision might be misleading. Okay, misleading. So I hope that clarify you on this. Okay, so any question before I move on to acceptance sampling? Any question?
Doktor, yang
Ya.
UO major minor tu dia memang akan bagi
Tak semestinya. Tak semestinya. Kalau tak dibagi, kita kena cari. Okay, kita kena cari. So, kalau tak diberi,
contoh kalau kata dia kita kena cari sendiri tu soalan macam mana? Dia tanya bagi ayat ke?
dia akan bagi jadual lah. Okay, jadual, dia berbentuk okay. Kalau dia beri macam ni, it's simple lah. Kalau tak diberi, you have to find. Okay, for example, dia akan bagi tahu, let's say, I give you a simple table kat sini. Some example. Okay, let's say you do inspection. Okay, you do inspection. Let's say this is you punya sample ataupun time of inspection lah. Okay, I can put it sample atau subgroup number lah. Okay. Okay, you take the sample number. Or easy to understand. Normally, I prefer to call it subgroup lah. Less confused. You have subgroup number. Okay, subgroup number 1. Okay, subgroup number 2, subgroup number 3, until you get it. Say, for you have 25. Okay, 25 subgroup. Okay, this subgroup may be taken at 8 in the morning. Okay, this may be at 9, or maybe because you're going to take 25, so maybe it will be closer. Maybe 8:20, take sample. Okay, maybe at 9:10 you take another sample, and so on. Okay, so when you plot it here, okay, out of, let's say you are taking every time you take, you will take n equal to 40. Okay, every 40. So what you're going to have is you have to classify that out of that 40, how many will be critical? Okay, how many will be major? And how many will be minor? Okay, it will be minor. Okay, in our case just now, it is given here up to this point. Okay, so it is given critical was 2. Okay, critical was given as 2. If this need 2. And then major was given 26. Okay, and then apa tadi? Minor 160. Itu diberi. Okay, which is on this particular day, which is not included in the original problem. Tapi that's how they give it lah. So from here you can calculate, for example, the D values and so on lah. But actually, every of these you have to have that numbers. Okay, how many here, how many here, and how many here, how many here, how many here, and so on. Okay. So how do you know that it is U not C? Okay. So excluding the 25, the 25 ini May 25, I just show the example saja. Okay. So let's say I remove this now. Okay. So the problem is not including that this 25. 25 May 25 is a later one. Okay. Let's say you have it 25 sample up to 25. Okay, don't confuse. What I meant here is, okay, what I meant here is you have, okay, let's say 20 lah. Let's confuse. I use different number. That's 20 subgroup to take it. Okay, so maybe this one is taken at 4 p.m. Out of all these, sorry ya, color sama. Out of all these, okay, you are taking how many here, how many here. Okay, so now you need to calculate for each column here, what is the U not C. Okay, so this will be, we want to know U not C over here, and over here you need to know U not MI, and over here you need to know, sorry, this is U not UM, not MA. Okay, measure. Here is U not MI. Okay, which is the standard value for critical, major, and minor. Right? So what is U? We have learned from the U chart. U is generally is equal to C over N. Okay, so because we are taking the overall here, so we are taking actually summation of C divided by summation of N. Okay, so meaning that you have to total all what you have in this row. Okay, whatever you have this critical, total all, and then multiply by you every time you are taking. Okay, every time you take how many that you have taken. I mean for the whole time you take is 40. Okay, for 40 multiplied by 20 lah. Okay, in that case. Okay, because every time you take 40, okay, how many times you take is 20. Okay, 20 subgroup. So what summation of C? Summation of C is whatever you have here, down here. Okay, similarly untuk MA. Okay, so this is will become not critical lah. Okay, not critical. So this C itu become macam ni lah sebab we are taking the overall lah. So in this case, what we get, U not MA. So it will be summation of whatever value that you get in this column, okay, which is what is the major defects, which is overall here lah. Everything that in that column you add, put it here. Okay, what you divide by 20 subgroup. Every time you take is 40. So this is where you get the estimate standard for ratio of major. Same thing also for minor. Okay, I hope that answers your question. But in this case, already given, so we are saved one step lah. Yeah.
One more. Boleh ke jadi N dia tak sama? Not constant, macam kadang 40, kadang 30 ke? Boleh ke?
Boleh. Because this is U chart. U chart, you can have variable sample size. So kalau that case, you cannot multiply like this lah. You have to add. You have to add it individually lah. Okay. You have to add. Katakan sini 40. Okay. On the first, he takes a 30, and then here maybe you say 50. Okay, here maybe 45. Possible? Can? So you have to add all these in order to put it at the denominator. Is it okay?
Yeah.
Right. Okay, so I move on to sampling, acceptance sampling. I think the rest you can follow yourself. Okay. Okay, I will go through also the slide that I just sent to you in the WhatsApp. Okay. Related to sampling. Sampling. Okay. Yeah, I think I have it here. Yes, acceptance sampling. Hope this is Westerfield. Okay, let me get it, my own slide on this. Okay. Okay, I cannot find it here. Let me check acceptance sampling for it. Acceptance sampling. Okay, nampak on the screen acceptance sampling.
Nampak, Doktor.
All right, thank you. Okay, this is from my old PowerPoint lah. Okay, so okay, I think the beginning part so is just general lah. Okay, so we were discussing on single sampling, double sampling. Okay, I want to show this part. Okay, acceptance sampling. This is we call it still general. Still general. We want to make a decision. Okay, for example, you receive shipment from vendor, okay, and then you want to decide. Okay, you take a sample and you do the inspection and you decide accept or reject. Okay, accept or reject. What happens if you accept? You will put this in your company lah for production ataupun for selling. If you reject, you have to reject the whole shipment. Okay, that is the idea of acceptance sampling. Let's say you the trailer is coming. You are doing business of shoes business. Okay, you receive this one trailer of shoes. You are the major distributor of shoes imported from Thailand, for example. You come in one trailer. So now you need to make decision to accept or to reject this shipment. Okay, accept or reject. So you must have systematic way of making decision. Okay, so when you accept everything, including some sample might be not a good sample, not good items. Kalau you reject, you have to reject the whole thing. Remember, when you reject, he has to go back and return to Thailand. Or you may say, okay, I will do 100% inspection, but they have to bear the cost of sorting what is good, what is bad. Okay, so when it is accepted, you send for further processing. When you reject, you can have the rework. you can have to do sorting. Okay, what is good, what is no good. Okay, which is of course costly. And then the one that you reject, you put it into scrap. Okay, sorting what's good and bad. Okay, so in the system, we have the system, these three systems. Okay, I mentioned already earlier, single sampling, double sampling. Okay, this is you take only one time of sample taken, decision is made. This one, we take one sample, cannot decide. So you have to do second sampling. So we call it double sampling. After second sampling, you must decide either to accept or to reject. Multiple sampling, this is allow us to take more than two samples. You take first sample, cannot decide. Second sample, cannot decide. Third sample, cannot decide. And then you take four sample, and only then you decide. So it's more than two times. We call it multiple sampling. Okay, single sampling system, double sampling system, multiple sampling system. Single sampling is very simple. Okay, we already discussed last class. You have accept number, you have defective number. So when the D is less than or equal to C, you accept. Okay, when it is more, you reject. Okay, example, you have 10,000 in that trailer tadi, 1,000 unit. The trailer come, okay, in this trailer ada 10,000 kotak. Okay, 10,000. So how many to take? This is just example. You take it 89. How you know that 89? There is a system to decide how many to take if you have the lot size of 10,000. Okay, ada guideline, ada jadual. Okay, yang kita akan rujuk sebagai kita panggil MIL 103. This is the code for standard lah. Okay, you can also Google to know more. Actually, this is coming from military standard. Actually, the US military standard, they order many things from suppliers. Okay, so they have this system, established this system. But now this system even used for civilian, not only for military purpose. Okay, 105, I think the number have changed now, become E. Last time it was D. Okay, so that in that document, you can know how many that we should take and how many we should decide. So in this case, you take 89, okay, from 10,000 to ambil 89 saja. Kalau you jumpa 2 ataupun kurang, you will accept. Kalau you jumpa more than 2, you will reject the whole trailer. Okay, that is single sampling. So this can be risky for the vendor ataupun supplier because, you know, getting the result of rejection is very, very costly lah. Okay. Okay, so that's single sampling. Double sampling. Okay, double sampling. Yesterday I showed you already, but in terms of different graphics. But now you see here there are two stages of making decision. You take sample number 1. Okay. Okay. And then if cannot decide, okay, in between gray area here, gray area, you go to second sample. If you can decide, except on the left here, you don't need to go to second sample. If you can decide to reject, okay, no problem, you immediately reject. But if it is in between accept or reject, you have to take second sample. After second sample, you must decide. It must be either accept or reject. If it's accept, meaning that defect from sample number 1 plus defect from sample 2 less than C2, which is criteria decision number for after second sampling, you accept it. But if it is more defect from sample 1 plus defect from sample 2, you will reject because it is more than or equal to reject number for after sampling number 2. Remember, this is summation. Summation. You summation apa yang rosak from sample 1 campur dengan apa yang rosak from sample 2, compare to decision number to accept or to reject after second sample. Okay, this is example here. Okay, given that the shipment is 9,000. Okay, let's say a trailer is coming. Okay, in this trailer you got 9,000 boxes of shoes. Okay, deliver maybe shipment from China, for example. So now you say, okay, we agree. You must agree with the supplier what type of sampling. Otherwise, you will have a dispute. Okay, so it can jadi court case lah. Okay, kalau you did not follow what you agreed, because rejection, the supplier will be unhappy because they are losing money. Okay, they have to bring back the items. Okay, so let's say you decide, okay, you agree in your agreement for purchase, we will do double sampling based on n equal to 9,000 and n1 is 60, n2 is 150, meaning that first time take sample, you take 60. Out of 60, you say, okay, if I get it one defect or less, I will accept all the 9,000. But if I found 5 and more, I will reject all the shipment of 9,000. Okay, so it's very clear, reject and accept. What happens if you get 2, 3, and 4, which is in the middle? Okay, because 2 you cannot decide, 3 cannot decide, 4 cannot decide. So you found that after doing the inspection of 60 units, you found that you have 3 defects, and they say, okay, I cannot decide. Now I need to take second sample. How many to take? And 2 is equal to 150. Okay, 150. So now you have to make decision. How to make decision? Whatever you got it in D1 plus whatever you got in second sample must be less or equal to 6. If equal and less than 6, you will accept it. How do you know this number? This number coming the standard that I showed just now. Example is from the MIL STD 105E. Okay. So if I get it more than 6, for example here, 7, D1 plus D2 equal to 7 or more, you have to reject. There is no gray area, because you got here 6, here is 7. So meaning that after second sample, you must decide. But if you allow gray area, that one is beyond 2 times sampling, you have to use multiple sampling. Multiple sampling will have N3, okay, and 4, so meaning that you have to take more samples. So of course more costly, okay, still cannot decide. So this is actually giving a chance for making decision to avoid making a mistake. Multiple sampling is continuation of double sampling. Okay, take more than 2 samples. So if we compare which sampling system to take, either to implement single sampling or double sampling or multiple. Okay, single sampling is the simplest. Multiple is, of course, is complex because you need to take many times sampling. Whatever you have taken, you cannot return to the lot. You have to take a new sample. Okay, so administrative costs, yeah, of course, multiple will be costly. Okay, quality information. Okay, these are factors influencing decision making. What information you get? Okay, do you have enough more information when you take more sample? Okay, number of inspected unit. Actually, when you take single, the size of single sampling actually is more because the N you take is big number. But when you take multiple, okay, the advantage is the total of all the multiple can be less in terms of number. Okay, the N1, N2, let's say N3, you have it 3 times. You total all these. Okay, in general, it is less than just taking the N here. Okay, you see the example that I mentioned, the first sampling that we take 89, okay, 89 here, single sampling. But when we go to double sampling, okay, how many was taken? Okay, the N1 in this case was 60. Okay, which is less number lah. Okay, less number. But of course, N2 depend on the system that you choose. Might be, okay, might be. This is just a sample randomly number taken. But in general, if we add up all this, because there are chances for you to do decision even going to second sample, third sample. Okay, but in general, we can say that number of units inspected will be more for single sampling, but multiple sampling it will be less because number of taking every sample is lower and chances to make earlier decision is there. Okay. Okay, how do we decide to form the lot? Okay, the lot should be homogeneous, maknanya it should be seragam lah. Larger lot are preferable and more economical. Lot should be comparable to material handling. How to decide the lot size for the inspection? Because material handling is the size that you use for transporting the items into the transportation. Okay, maybe the pallet size, packaging size, and you need to implement random sampling. Okay, if you got one trailer, which one that you want to take? Okay, do you take only the one that is near to the to the door here, or you want to take somewhere in the middle, or where it? So this is really follow random number. Okay, to avoid the bias. Which one to take? Okay, that is a system for selection. Okay, based on arrangement in terms of width, length, height. So based on random number, you pick randomly. Nobody knows which one that you're going to pick. Okay. So we need also to supervise this inspector to avoid bias. Okay. So I think that's all for today. There will be, okay, I will continue on this, especially on how to evaluate how good is the sampling system. Okay, because there will be a issue of what we call it customer risk, producer risk. Okay, when we are dealing with sampling. Okay, when we get sampling, there is a risk for rejection of items. Okay, when the items are good, we reject. So there's a risk. Okay, and when the items are bad, we accept it. So those are the risks that we may be facing. Okay, any question before we stop?
No question.
No question. Okay, saya nak tanya Fatimatul, what do you learn today from this class? Fatimatul? Okay, I try another one. Alvin Ong, Alvin N. What do you learn today? Okay, demerit. Okay, itu saja. Okay, Abdul Rahman Ali, what do you learn today? So no response. Abdul Rahman. Adriana Ardini. Okay, what do you learn today? Okay, volunteer. Can somebody summarize what you learned today? No volunteer. Okay, Julian.
Okay, boleh sir?
Yeah.
So today we learn about demerit per unit chart and
Okay.
quality rating system and the ways how to calculate the U not critical, major and minor. And we also look at single sampling, double sampling, log formation, and render sampling.
All right. Okay, so everyone have to start thinking of preparing for test number 2. We will decide next week when to set for a test number 2. Okay, so I still owe you that for the test 1. I will return to you as soon as possible before the test 2. Okay, thank you very much.
Test 2 subjek apa chapter apa?
apa yang kita belajar dalam attribute control chart, okay, the chart yang kita tengok itu QSUM, PWMA, apa semua itulah. Okay, so many type of charts we have learned, right? So those will be included in test number 2 lah.
Doktor,
Ya,
saya tanya dia yang check nanti masa test tu kami kena pakai graph paper ke ataupun just sketch saja?
you boleh sketch pun boleh, guna graph paper pun boleh. Kalau your sketch is clear enough, so that will be fine. Tapi kalau you rasa your sketch tak apa clear, you can use graph paper.
Okay, terima kasih doktor.
Baik, sama. Right, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.